Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
Okay, so this is the R Studio project, R project. There are 5 problems. This is second problem of the 5 problems. We're tackling problem B, law of large numbers. So in this, it's basically talking about how when you take an average of large numbers, they tend to converge to the mean of the population. So we're told to create a function called mymovave. It's got 2 or more parameters. First parameter is the size n, and then the second parameter is a function variable, typedist, and this variable basically is going to direct us to a function call, which is also going to be written by us. It's going to be, so this typedist is going to point to a Cauchy distribution sampler and a t-distribution sampler, and each of these functions we need to create 1,000 observations and then plot the moving average as the size of the window increases. So let's start scripting the problem B. Right off the bat, we know that we have to create some samples, and we need to randomize them. So we need a library that can handle that. We are going to import that library. It's called Ramify. It's basically populates our variables with random numbers. So that's the first thing we do, and you can see that we have already installed it. You can install it by clicking this button and typing in Ramify, and it will install it for you. So the first function that we need to create is called mymovave, and we are going to define it this way. Oops, the other way actually. And it's a function, and the first term is going to be n, and we default that to be 1,000. And the second one is going to be called typedist, and this is going to be a function, and we're going to just default that to tdist gen, and we're going to define that later. And finally, we need to be able to take in other variables, other arguments after that. So once we did that, let's start the function. So the first thing is the random variable. We need to populate that using the typedist function, and that function takes the number n, which is the number of samples, and then the rest of the arguments are copied in. Next, we need a window size. A window size is going to go from 1 to n, and then move average is to be calculated. Move average is going to be of size window size, and then the result is going to be a data frame, and it's going to have window size and move average. And then we're going to create the averages. So for I in window size, what do? We go into the loop and we take the result dot move average, obviously. Surprised it's not giving me the option. I hope I didn't do something wrong here. Okay, so the ith value, we are going to calculate that as a mean of x going from, this is the part that creates the different windows, so 1 to I. So as I increases, we're taking bigger and bigger sizes of windows to average, and that's good enough for this mymovave, and all we need to do is return the result. And that's the final step here. Now that we have the mymovave function done, we need to declare typedist. So this is our t distribution sample generator, and this is obviously a function, and I'm going to put a space here just to make it nicer. And this function takes argument of n, which is the same as up here, and then it's going to take mean value. I'm going to default that to 0, and variance value, I'm going to default that to 1, and degrees of freedom value, I'm going to default that to 10, and that's all it takes. And the x, we're going to use the RT function here. It creates n samples with degrees of freedom equals to degrees of freedom, and then we're gonna do this part is normal distributed, so we need to make that t distributed, and that's the part we're doing right now. We're gonna multiply that by the square root of the variance of variance, and then the variance of the t distribution, df minus 2 divided by df, and that's it. So we just need to return x at this point. And that's our typedist. So next we need to define the Cauchy disgen. This is the where am I typing here? So Cauchy distribution sample generator, and this is also a function. So we are gonna basically, so this is another of those functions. This is one of them that goes into typedist. This is another one that will have to go through typedist. So it has to have this format right here. It has to start with an n. So n, and we are not going to make it too complicated. We're just going to leave it as n samples, and we're going to center that around 0. So this one is going to take, we're going to call it x random, and we're going to take random variables, random samples of size n, and each the minimum value is going to be 0, and the maximum value, this is uniformly random, maximum value equals to 1, and then what we're going to do is create the x, the random variable out of that. It's going to be tan of pi times x rand minus half. So that centers it around 0. and that should give me the random variable that we need, sampled random variable that we need. So we return x at that point. So right here we're told that we need 1,000 samples, 1,000 observations. So n equals to 1,000. First we're going to do the Cauchy distribution. So we're going to calculate the Cauchy averages. Let's call it Cauchy averages. And we're going to then call mymovave. Yeah. And we're going to give it the size of n. And then we're going to call Cauchy disgen. And that should calculate the samples and that should calculate the averages and put it in Cauchy averages. And next step, we're going to do the t distribution with a mean of 0, variance of 4. We're going to change that up a little bit, and let's do the df as 10, and then we can calculate our t averages, and that should look pretty similar to what we had above. N typedist gen, and then we need the m, the v, and the df, and that should be good enough for this. And finally, what we need to do is we need to call the library gplot because we want to plot it. And then we are going to basically start plotting the Cauchy averages. So this is section B, so I'm going to label it section B1 scatter, and we're going to use ggplot for this, and then we're going to try to call up Cauchy averages as a data set, and then we're going to call up the statistics. And in statistics, we're going to describe the x variable is going to be window size, and the y variable is going to be moving average, and that's it for here. And I'm not going to do any labeling or anything, I'm just going to print this out. So this one is going to be our B2 scatter, and this is going to have to deal with t averages, and that's it. So once we run this, I'm going to run it one more time. Alright, so once we run this, we can see the plot over here. We'll run the plot separately, and then we're going to call the plot. Oh, window size did not get found. Alright, so that's because this is window size, not Windows size. So that's a problem. I'll fix that. There it is. Where's my data? The data looks good. Why isn't it showing? Oh, because I didn't plot it. Oh, my bad. So what I need to do is right after B1 scatter, I need to add the points, the geom points. And that should do the trick. Let's do that again. Let's try that one more time. There it is. So as n goes larger, the Cauchy one basically starts going closer and closer to 0. Let's try the same thing with the B2. Let's try it. So this is a T distribution ones. Oh, I made a mistake. This is B2. Let's call that again. Yeah, so as n goes towards 1,000, this is getting closer and closer to 0. That's what was expected. All right, thank you very much, everybody. See you for the next problem.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.